Before we do that, I got to introduce a new line to you. Real quickly, let me just review the old line we talked about. What did I just draw up there? That's a what line? 19, that's a tangent line. All right, now I have a line that intersects twice. If that happens, anybody want to give it a roll? Give it a try. If it intersects twice instead of once, try it out. Go ahead. Secant. Secant. All right. So a secant intersects the circle two spots. All right. All right. Now that we know that, I have 3 diagrams up here. I got 3 diagrams, all forming an angle on the outside of the circle. Before I show you how to find the angle, I want to go through 3 of you right now in class and say, how is angle B, A, and A formed here? Angle B, those are 2. Angle B is formed by 2. 17?
2 tangents.
Those are 2 tangents. Good. All right, let's use our vocab now. How is angle A formed on diagram 2? Angle A is formed by A. 6?
1 tangent and 1 secant.
Good job. Secant and tangent. Yep. And diagram 3, how is angle A formed? 6 again. 2 secants. Good. The good news, I don't care how it's formed. If the angle's on the outside, it's found the same exact way every time. So angle on the outside. Remember yesterday for floater? What did we do to the 2 arcs for a floater angle yesterday? What did we have to do to the 2 arcs for a floater angle? 13?
We added them.
We added them, correct. Now for an angle on the outside, we're going to subtract them. Okay, we're going to subtract the 2 arcs in between. And this is kind of tough for me to write, but I'm going to just put major arc minus minor arc. You always do the bigger one first, smaller one second. And notice I left some space between the equals and the parenthesis. What do you think I'm going to plot there? What did we do yesterday? You take half of that. Okay, we take half of that. You don't write this down. I'm just going to show you. So for instance, if I wanted to find angle B, I asked you to find angle B. I take half, name the 2 arcs I would subtract from each other now. Don't bother writing this down. I don't want to waste time. I want you to focus here. What are the 2 arcs I'd be subtracting? Name the major and the minor arc I'd be subtracting here. George, 1.
ADC.
Okay, I would take whatever arc measure ADC is and subtract what from it?
AC.
Good job, AC. Let's go to that second diagram now. What about, how would I find angle A here? And when we say major and minor, those are the ones, hey, in between the angle that's formed. So give me the 2 arcs I'd subtract here. 2.
BD.
BD, good. I take 1/2 of BD and subtract what from it?
BC.
Got it. Everyone see what I'm talking about? The arcs in between. All right? So you ready to do this? No, you're not. Because I still got to talk about a couple more. Hey, we all agree. Take a look at those 3 diagrams. All those angles are clearly on the outside, right? Clearly on the outside. So yesterday we talked about 3 angles that are clearly inside. Now we just went over an angle that's clearly on the outside. What happens if you have a half and half angle? Some of it's inside, some of it's outside. I call them tweener angles. Get that? Tweener, between? Got that, Colin? Yep, I know. I made that up myself. Very proud. What happens if you have an angle that's half inside, half outside? A tweener. All right, it's fun to say. I know, tweener. Take a look at my angle CAB here. Do you guys see how AB, that's a what, by the way, AB? That's a chord, that's inside. And then CA, which is a what? Tangent's on the outside. That's a tweener angle. All right? So if I have a chord and a tangent, I'm going to take half its arc measure. That probably would have helped a lot of you out last night, doing a couple of those king size problems. So if it's formed by a chord and a tangent, a tweener, you take half its arc, we're done. Anybody know why I don't call this an inscribed angle, even though A is on the circle? How much do we know here, this unit? Why don't I call that inscribed? A is on the circle, why not? What's the problem? The other two have to be what? Chords. The other two have to be chords, and CA is not a chord. That's why I can't call it inscribed. And then the other type of tweener angle you'll see is an angle formed by a secant and a chord. I'm talking about angle BCD here. And I got bad news for you. Bad news. How do I find that tweener angle, secant and a chord? There is no rule, but I'm still going to ask you to find it. How are you going to approach this if it's not, oh my God, I can't take half, I can't subtract, I can't add, it's not equal to, but he's still going to ask me to find that angle BCD. It's still possible. What's right next to it? What's right next to it? An inscribed. Can you find inscribed? And then what's the relationship between these two bad boys? Okay, so you can find it. I just don't have a magic rule for it, but you can still find it. All right? So we're all good with our two tweeners. All right? One you can find with the rule, one you cannot. All right, let's do this. Let's do this. Find CAB. Inside, I'm going to keep asking this every time. Is the angle inside? No. Is it outside? No, it's in between, isn't it? It's a tweener. All right, so if it's a tweener, I got to think to myself, how's it formed? A couple questions for you guys here. 7, what's BA? And what's CA? Okay, so this tweener angle is by a chord and a tangent. I have a rule for that. We just went over it. It's equal to half its arc measure, which would be CB. All right, that's formed by a chord and a tangent, so I take half its arc. I'm not even going to ask, so CAB is going to be 70 degrees. Two, find minor arc AB. Minor arc AB. Not the major, the minor. So I don't know, what do you guys feel? You want to use the 160 or should we use the one next to it? We can get to it either way. 14, we want to use this 160 or the angle next to it? There's no wrong answer here.
No, just use the 160.
Okay, let's use the 160. If that's 160, what's major arc BA then? What's major arc BA if that's 160? I'll get to the minor in a second, but if I'm going to use 160, I can only find the major arc. 17, little help finding the major arc.
320.
How'd you get it?
I just did 160 times 2.
Yep, remember, that angle's half the arc, so I double it to get the arc. So if that's 320, somebody tell me how you're going to find the minor arc then. Whoa, 3. There we go. So minor arc AB, 300. 40 degrees. Could I also have done this is 20, double it and get 40? Yep, I could. All right. Just noticing that's a tweener. Where's angle X on number 3? Inside? Here we go. Here's my list of questions you should be asking yourself. Inside? Nope. Outside? Outside? Okay, discussion is done. It's done. Once you tell me outside, it's equal to half of 2 arcs added or subtracted. What did we just go over? Subtracted. Once you say yes to outside, our discussion's done. 1/2 of 2 arcs subtracted. And you guys can clearly see the 2 arcs we're working with. A little smaller. 90 minus 20. And that'll end up being 30, half of 70. You guys, we're done with the easy ones. Can we go right to the above average ones now?
Sure.
Woohoo! Here we go. Above average ones. 38, inside or outside? Outside. All right. So we know how it's formed, right? Outside. So 38, the angle on the outside was formed by taking half of 2 arcs being subtracted. We at least know one of the arcs, right? The minor one. What's the measure on the minor one? So something minus x. I need your help. How the heck do I figure out what that arc is? Right? Because that's what's going to go in first, minus x. Well, we do have 140. So if I have 140, how much is left for the rest of the circle then? I have 140 degrees for that arc. How much is left for the rest of the circle? 220, right? I don't want to put 220 here though, because that's this arc and x together is 220. This arc and x together is 220. If that's already x, and I know these will give me 220 total, any idea how I can write that one now? You got 220 total. One piece is x here. What's the other piece then? What's up, Luke?
220 minus x.
220 minus whatever that arc is, x. There you go. Good, Luke. So 220 minus x. We okay there? That was a tough one. Yeah, above average. Darn right it was. All right, clean that parenthesis. God, clean that parenthesis up. Have some self-respect. 220 minus 2x, and this was the same issue we talked about yesterday. You either distribute the 1/2 for me right now, or you get rid of it by... What if I don't want to distribute? What if I just want to get rid of the 1/2? Multiply both sides by 2. Yep, your call though. So go ahead and finish this up. So distribute 1/2 or multiply by 2. Finish up if you're not ready, but let me know when you are. 11 when you're ready. X. 72 degrees. We okay? 60 degrees, number 5. Inside or outside? All right, we're done talking. I know it's formed by taking half of 2 arcs being subtracted. One of those arcs, I can see the minor one is x. Based on the work we did on number 4, how do you represent the other arc then? If that arc's x, how are you going to plug in that arc there, which I need to subtract? Oh, 18.
It would be 360 minus.
Darn right it would be. 360 for the full circle minus what I already have. So 360 minus x. Major minus minor. Clean it up and go. When you're ready. Ooh, 4. I got 4. Working.
Yeah.
Should multiply by 2. Oh, there we go. We needed that thing plugged in. You need a charge, Molly?
Yeah.
Get over here. Just do it while we're in class here. I have no idea. 120, how's that sound? My answer key? Yeah, 120. All right, any issues? Yeah, you don't want any of this smoke, bud. You don't want any of this smoke. Yeah, get that off, please. I'll implant those earbuds right in his ear. Questions? And I don't even know the kid either, so all good. All right. I know you were waiting, and the answer is yes. Here we go. King size circle ones. Everything goes now. Floater, inscribe, central, outside, tweeners. Anything goes here. Anything goes. All right. I tried to warn you guys yesterday. I'm warning you again. Read the darn directions. There's a key piece in here to this problem that we cannot live without. And it's not that AB is 150. It's right next to it. Those two are equal. What is AB in the circle? What is, well, AB and AD. What are those? 15. What are AB and AD? Chords, yep. You guys know anything from this unit if the chords are congruent? So are the arcs, yeah. If the chords are congruent, so are the arcs. So what they're trying to tell you right here, take a look. What they're trying to tell you is, hey, if chord AB is congruent to chord AD, their arcs, AEB and arc AD, are congruent to each other. That's what it's telling you. And that's huge here. So read the directions. All right, let's start this off. AB is 150. So do you guys know another arc right away then? AD is also $150. That's what I got from AB, the chords being equal. All right, you know my deal. Can we try to find any more arc measures before we go? Don't worry about A through F. I don't care. Any other arc measures you guys know? I think you should. Scott! BD is 60. I think so. Yeah, it is. How'd we get there? Okay, there you go. Thank you. I wasn't thinking that. Yep. One job. 360 degrees in a circle. Got me there. And I think you guys should be able to find now arc EB and EA. Let's start with arc EA. Degree measure of arc EA. Going. Romeo? 30. What? Hey. Diameter, right? EOD is a diameter, cuts it into two 180s. What's going to be EB then? You could do it a couple different ways, but what's going to be EB? That should be how many degrees arc EB? Who? 2.
Wait, which
E to B. What's that measure?
150? Or wait, sorry. Wouldn't it be?
I got the 120. There you go. All right, you guys ready? I got all the arcs I can find. Let's bust this out.
Wait,
What?
I'm sorry, EB is 120. Wait, which one is 120?
EB is 120, right? Because it's got to add to 150 with EA, which was already 30.
Oh,
Or it's got to add to 180 with the 60 because it's a semicircle.
oh.
All right, part A is already done. Measure of arc AD is also 150. All right, this is on you guys now. Here we go. Measure of angle BAD. Go through the questions in your head. Inside or outside? It's inside. All right, go down the three that are always inside. Is it central? Nope. Is it inscribed? All right, there you go. So it's, do I know the rule or not? Half of which arc am I going to take? BAD. Take half of 2. Again, redemption.
I'm blowing my nose right
Oh,
now. Sorry.
multitask. Learn how to do it, Molly. Come on, if you're going to be in this class with me. 8. Take half of what?
Half of
BAD, Callum. BAD. Don't get rattled. I got to give you a tissue too.
wait, that's not. It's inscribed.
It's inscribed.
Oh, 60. Yeah.
Hey, all right. Yeah. Take half of 60. Good. 30. Put it in the diagram. You never know. You may need it if you freeze on a fact or there is no fact. Angle ACD. Ooh, what are we looking at here? Ooh, inside? No, outside.
Yep.
Okay, discussion's done. 1/2, 2 arcs subtracted. Let me know what those 2 arcs are. Oh!
Okay.
ACD. What are the 2 arcs? The major and the minor in between them. 11.
What do I do?
What is going on here today? Like ACD out is on the outside. So we said, hey, we're gonna have to subtract 2 arcs. What?
Oh yeah, we're subtracting the 60 and 150.
There you go.
After something.
What's that? 45?
Yeah.
Okay, so 45 for angle C. Oh boy, I got 3 more to go. I can just imagine where this is going. How about the measure of EFV? All right, take a look at that angle, everybody. Inside or outside? Inside. All right, here you go. Is it central? Central?
No.
Nope. Inscribed? Nope. It's got to be a floater. That was yesterday. A half of. Oh boy, here we go. All right, before I call in a number, I am asking the 2 arcs I should add together to get angle EFB. Its arc and its vertical angles arc. Any more detail I need to give this person before they get called on? We all good? 11, redemption. Redemption, maybe. What am I going to add up?
Yeah, you're gonna have 120.
And the vertical angles arc, which is?
The 150.
All right, there we go. Whew. Half of 270, everybody. 135. Might need it, maybe not. Oh, geez, 2 more to go. Measure EDA. Inside?
Yep.
Central? Inscribed.
Yep.
All right. So we're about to take half an arc then.
You want the answer?
Nope.
Okay.
What arc should I be taking half of to find EDA? 5?
Yeah.
EA, which is 30. That's 15. And also, I'm just looking at this now. You freeze and you didn't know it was inscribed. Could you find that angle right there? And now it's 2 angles out of 3 in a triangle. Okay, if you froze. And then EDC. Oh, this one. Oh, boy. Oh, boy. I don't know about this angle. Inside? No. Outside? No, this is a tweener, isn't it? Half of it's on the outside, half of it's on the inside. All right, well, what's ED here? diameter, and what's CD? Okay, so it's basically a chord and a tangent, right? A chord and a tangent. And I gave you that rule today. If an angle's formed by a chord and a tangent, you take half its arc measure. Not to dirty this up even more, but what's the arc measure that's in between it? What's the arc measure in between it? It's how many degrees? 180, isn't it? It's half a circle in between it. Yes, no? Maybe some of you saw a different thing, and I love it if you did. So that's a 90-degree angle. Did anybody see anything different? See a theorem? Oh, now you want redemption? You good? You got to blow your nose again, or you good?
It's the diameter and the tangent, so it's going to make 90 degrees.
There you go. Radius drawn to the point of tangency is perpendicular. I will give you credit for sucking it up and being here, though. Okay? Respect. A lot of kids would have bailed. Any questions? All right, you got one on your own right now. See if we can handle this one. I believe this was an old Regents question. See if you can handle this one. Inside or outside angle P? Outside, right? So that's today's topic. Angles outside, I take 1/2 of two arcs being subtracted, and I know the first one's 56. How can I find the measure of arc EZ now? How do I find them? So I can plug it in right here. How's the measure of arc EZ being found? 16.
You take 180 minus 56.
Yeah, this is a diameter. So this is a semicircle, 180 degrees. And what was that arc measure?
Is it 180 minus 56?
It is, which would be?
Oh,
That's what I'm just asking for.
124.
124 in there. So angle P. What would that come out to be? Anybody? 34. Trust in you. All right. All good? All right, get going. Get going. Get ready for the king size coming at you. 2 of them on Thursday. Tomorrow's big day of review. Big day of review.